This is where we stopped during our last class. And I have told you how to reach to this point. Okay. Now out of this table, you know, A0 to A10, this entire A0 to A10 will go directly to address lines of the memory. It will go directly to address lines of the memory. And I told you the remaining address lines of 8086. See, all these are address lines of 8086. Address lines of 8086. So remaining address lines from A11, from A19 to A11 has to go as an input to the decoder logic. Right? Now, how do you select the inputs to the decoder logic? I have told you that what can be the input A, B, C, right, to the input of the decoder logic, which differentiates your RAM 1, RAM 2 and RAM 3, right? You know that A11, A12, A13, A11, A12, 13, A11, A12, 13, right? You see here, your A11, A12, 13, it is 00 for RAM 1. It is 001 for RAM 2. It is 010 for RAM 3. And it is 011 for RAM 4. It is unique. But you have only 4 RAM over there. Why can't that be? Why can't these address lines be the select input? Right? ABC select input. Right? You can take ABC, which is the select input to the decoder, to select RAM 1, RAM 2, RAM 3, RAM 3, RAM 1, RAM 2, RAM 3, RAM 4, and remaining A14 to A19, you can use it for chip select of the decoder, right? See, I told you all this A0 to A19 is used as a entire address lines coming from the 8086. Out of that, A0 to A10 are used for connecting the direct address lines of the memory itself. Hope all of you remember what I told you in the previous class. Can you tell me why A0 to A10? I am separating for connecting directly to the address lines of the memory. Why in A0 to A10 there?
11.
Because it is 2 kilobytes of memory, right? Your memory chip, your 2 kilobytes memory chip it requires 11 address lines. So 11 address lines of the 8086 microprocessor will go directly into the memory chip. So remaining one, which is from A11 to A19, we have to use as an input to the decoder of the decoder logic. Now out of these A11 to A19, which one you will select for ABC? Which will uniquely define RAM 1, RAM 2, RAM 3, RAM 4 based on those 3 address lines. You have easily found out that A11, A12, A13, it is 00 for entire RAM 1, and it is 001 for RAM 2, and it is 010 for RAM 3, 01 for RAM 4. So you got all the inputs now, and remaining lines which are all zeros, right? Can you see A14 to A19 is all zeros combined with some gates and give it as a chip select enable for the decoder, right? So this table is going to give you lots of information for decoder logic. Okay, so using this table, now let us write the decoder logic. I told you, see, A11, A12, A13 can be used for as a select input to the decoder logic. You're going to use 74LS138 decoder logic to decode the address. Have you understood this? Try to understand this. Now, so three lines, A11, A12, A13 will go to the select lines, right? And can you see, to select this particular decoder logic, that means to enable this particular decoder logic, right? To enable this particular decoder logic, you need to give proper inputs to this, right? Right? You need to give proper input to G1. G1 has to be 1, G2A has to be 0, G2B has to be 0. Now let us look at the table, right? You can see that all from A14 to A19, it's all zeros, right? It's all zeros, yes or no? In this address range, in this entire address range from the table, you know this A14 to A19, it's all zero coming, right? But see, these two are directly require 0, yes or no? Your G2A, G2B requires 0. So you can connect directly A14 and A15. Because for entire address range, A14 is going to go 0, A15 is going to go 0. That means this is enabled, yes or no? Now you have to enable G1. Use remaining address lines. What are remaining address lines? A16, A17, A18, A19. But that is 0, right? How do you make it 1? Use an OR gate. Right? So all these are 0, 0, 0, 0. 1 will come here and this will get 1. That means the content of the address lines A14 to A16 is used to enable this particular decoder logic. Right? So done. If you do this, your entire address decoding is done. See here, this is connected to RAM 1, yes or no? Why this has to connect it to RAM 1? Because see, whenever 0, 0, 0 comes here, RAM 1 has to be selected. That means this will go directly to the chip select of the RAM 1. This will go directly to the chip select of the RAM 2. This will go directly to chip select of RAM 3. This will go directly to chip select of RAM 4. Right. Now let us take an example of generating an address, and we will see this decoder logic will select proper RAM for that particular address. Okay, tell me any address between this range. Our address is from 0000 to 01FFFH, right? Whatever specification is given for you, according to that, your memory map is from 0000H to 01FFFH. And for this memory map, we are designing address decoder logic. Have understood this? Okay. Now let us generate some address. Tell me which address I should generate. I can generate. Take an example. 00. How can you tell that? Your address has to be in this range, right? Your address has to be in what range? Okay, 0000 to 07 FFF. Right. Okay. So which address you want? 6FF or 006F, right? Okay. 006F. Which RAM it is supposed to be? RAM 1, right? Now let us see from this circuit whether this address is going to generate this or not. Okay. It has to select RAM 1, right? Now we will just cross check this. We'll cross check whether it generates, whether this RAM 1 will be selected or not. Okay. So now you said 0006F. Okay. Just write it A19, A16, sorry, A18 dash 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 A0, right? Right. So A0 to A10 will go directly as the address line, right? Address line of the RAM 1. Right. Now remaining one. Okay. Remaining A11, A12, A13, A14, A15, A16, A17, A18, A19, right? Okay, can you tell me what are these values? All zero, right? All zero, yes or no? All zeros only. That means what is going inside this A11, A12, A13? 0, 0, 0. Right? Now, what is coming here is 0, 0. What is here is 0, 0, 0, 0. What will come here is 1. So, this particular decoder logic is enabled. Now, because of 0, 0, 0 here, which particular output will go low? Go 0. RAM 1 will go 0. Right? So, all this will be 1, 1, 1, 1. So, this one is directly connected to, okay, this is my RAM 1. This is my RAM 1. RAM 1 chip select bar, right? This is connected to RAM 2 chip select bar, okay? This is connected to chip select bar of RAM 3. Now similarly this is connected to chip select bar of RAM 4. Now which RAM will be enabled now, tell me? RAM 1. RAM 1 will be enabled. This RAM is not enabled. Why? Because the address generated by the microprocessor is for that RAM only. And this decoder logic has to select that particular RAM. The purpose of having this decoder logic is to select either RAM 1, RAM 2, RAM 3, RAM 4, depending on the address generated. Suppose if the microprocessor generated any address which belongs to this RAM 4, right? So what is the address belongs to RAM 4? Tell me. That is 01800 to 01FFF. When microprocessor generates any address in this range, this decoder logic, whatever you have designed, okay, has to enable this. It means you're getting input accordingly, and this particular line will be enabled. This will become 0. All other will become 1. When this 0 means this particular chip will be enabled, right? You have chip select bar here. Chip select bar means if this has to be enabled, it has to give a 0. Have you understood this? Okay. So this is the way you can just design a decoder logic, address decoder logic, okay, for 8088 microprocessor. Whatever you're designing here is for 8088 microprocessor, because the memory which you have here is byte addressable. Byte addressable means it is having 8-bit data bus. 8-bit data bus. Okay. And your microprocessor is also 8-bit. Right? So there is no mismatch at all. Right? Memory also 8-bit, microprocessor also 8-bit. So there is no problem at all. When the problem comes, when the microprocessor is 16-bit, it's having a capacity of taking 16-bit data, but your memory is capable of giving only 8-bit data. During that time, we have to completely modify our entire design. Instead of using one memory chip, we have to read from two memory chips, right? Because microprocessor can read 16-bit of data. Have you understood? If memory chip is having capability of giving 16-bit data at a time, then there's no problem, right? You can interface the way which you have learned now. But in the case where your memory is byte addressable and your microprocessor is 16-bit, in that case you have to go for a different method called as even and odd addressing. That means you are using two memory chips at a time. Lower byte will come from one of the memory chip, higher byte will come from the other memory chip. Okay, we will see how does it work. So have you understood this? If I give you different specifications, can you design this yourself? Okay, so how to start, right? Okay, So this is called as increment. See, there are two ways we can do this. Okay. See here, what we have seen now, this method is called as absolute addressing. See, the purpose of absolute addressing here is that we are going to use the entire address lines, okay, for connecting to the input of the decoder logic, which is called as absolute addressing. Okay. Now, incremental addressing time. See, you know that this particular table, okay, for this address range, you can see that, see, all these are zero, right? All these are zero. See, except this, okay, these changes, all are zero for all the 4 chips, right? Can you see this? Yes or no? Right? So, always you have seen that your A13 is also all zero. Yes or no? Can you observe in this? Right? See, your A11, A12 is only differing because we want to give input 3 inputs to a decoder. We are considered A13. Otherwise, A13 is all zero, right? For this particular design, I am talking about. For this particular design, so I can very well, okay, I can also do very well, okay. Directly short this, yes or no? Directly short this and connect to ground, right? We all know for this particular design, your A13 is always zero, right? That's why for this incremental addressing, you make this A as a permanent zero, right? Now, similarly, you know that G1 you want high always, right? And your all the other inputs are zero. Yes or no? So that's why, like you have done this grounding, okay? You do this G2A and G2B also grounding. Understood this? And also you need G1 to be 1, right? And this G1 to be 1 can be connected by using 5 volts. 5 volts. Have understood this? Okay. So difference between absolute addressing and incremental addressing is, in absolute addressing, we will make use of entire address directly from the microprocessor, okay, as an input to the decoder logic, which we did earlier. Now, in incremental addressing, since all the addresses are all zero, for entire address range, you know it's all zero, right? It's all zero, there's no change happening, right? And you know that A13 which you have given an input A is permanently zero for entire range. So why we should take it from the microprocessor in that case? Do we need to take a microprocessor? No. Since it is permanently zero, you ground it directly. Similarly, you know these things can be just simply grounded and use only those address which are differing from RAM 1, RAM 2, RAM 3, RAM 4 for the input of the microprocessor address lines. Okay, so have you understood difference between absolute addressing and incremental addressing? In absolute addressing, use entire A19 like I have shown here. See this one. You use everything, A19, everything. But is it? See, this A13 is permanently zero, right? In entire address range, it's permanently zero. You know that. But do we need to use A13 line there since it is permanently zero? Yes. Can't you directly ground it? Is it going to make a difference for you in the operation? Just try to understand this. Suppose if I make this permanently ground, is it going to make a difference? No. Suppose if I make this permanently ground, is it going to make a difference? Because throughout the address range it is zero only. Suppose if I make this ground it, instead of connecting A14 here, does it make a difference? No. Understood. Now suppose I'm going from this zero, I'm making this 1 always for entire addressing range. Of course, 0. That's why, see, that's why I'm grounding it, my dear. So entire range is 0. So instead of connecting A14, A15, I'm grounding it directly. I'm not connecting it to address lengths of the microprocessor. I'm not connecting A14, I'm not connecting A15 for this. I'm grounding it, right? Similarly, instead of connecting A60 to A19 and getting connecting a NOR gate and making it 1, I will not use this. I mean, I will connect this to plus 5 volt. That's called incremental addressing. Incremental addressing. This is for absolute addressing. Okay, in the question it will be specified for you, right? Whether you want to go for absolute addressing mode or incremental addressing mode. Accordingly, you just all this information will come from a very important table. This table is very important. If you make any mistake in this table, okay, this table, then all subsequent steps will become wrong. We will do some examples during our tutorial period for this, right? You have to work out. You don't have to, you should not simply sit and listen to whatever I say, but you work out, okay? Then only you can do something, okay? Fine. So this is memory interfacing for 8088. Now, I'm giving you one more example. Okay. Listen carefully. One example I have given. What's that example? Interfacing 8 kilobytes of memory using 2 kilobytes. Okay. I have already explained this step. This is another example. This is another example. Okay. Now, example is to interface to 8088 microprocessor. Listen carefully. You have to interface now to memory, right? You have to interface 4K of memory, okay, which is 2716. The chip number is 2716, okay, which is a ROM starting from the address 0000H. Similarly, for the same microprocessor, you have to interface 8K memory, okay. The memory chip, the chip number is 6116, which is an SRAM, starting at an address 0800. Right, this is the specification given, right? You have to interface 4K memory 2716 and 8K memory, which is 61116, starting from the address 0800. Can you tell me what is the ending address for this entire ROM? If the starting address is 00000H, can you tell me what is the ending address? 00F. Hope all of you know about this. I'm sure maybe doesn't know. Come only for the attendance, right? Learn something. How do you get the ending address? All of you know about it. I have taught from in one of the class. I shared slides also. You need to know about it. Without that, you can't do anything. Yes. Fine? Okay. Okay, can you tell me what is the ending address for this? Starting address of ROM is 0000. Ending address is 00FFFH. Okay. Now, for 8K, starting address is 0800. What is the ending address? 09 Yaf. This is very important. Unless you know this, you cannot go further because your table entire will depend on this. Okay, what next? What next? What is given? What is given? See here, in this question, try to understand. Your requirement is 4K ROM. Okay, try to understand this. Your requirement is 4K ROM and 8K RAM. Okay, the requirement is 4K ROM and 8K RAM. Okay, and this is from starting address 00000H. Okay, and this is from starting address 08000H. What is given? What is given to you is 2716 memory chip. 2716 memory chip, and also 6116 memory chip. Right. Always remember, if the number 27 comes in the beginning, it is actually ROM. It is ROM chip. Okay. If the number is 61, it is RAM chip. How do you find out what is the size of the chip? Right. Suppose if I say the memory chip given is 2716. Immediately with the first two number, you say it is ROM. What is the size? Just take last number, okay, remaining number divided by 8. Okay, so that much 2K, that much size is that is the memory capacity of that particular chip. So now 276 is, what is the capacity of 276 memory chip? It's a ROM. Capacity is 2 kilobytes. Have you understood this now? How do you find out the capacity of the size of the memory chip from the number? I'll repeat once again, those who are not understood. 2716, the memory chip given to you. See, you have to interface 4K memory. Okay, that is the specification. But what memory chip given to is 2716. Okay, now how do you find out the size of the memory chip? From the last, see, first two number will go for the identifying whether it is ROM or RAM. The last two number, whatever 16 is there, divided by 8. That is the size of the memory chip. Now tell me, what is the size of the 2716 memory chip? ROM 2K. So how much memory you have to interface? How much ROM you have to interface? 4K. So how many 2716 you have to use? 2. Similarly, 6116. It's a RAM. 61 indicates it is a RAM. And last 2 indicates 2 kilobytes. So how many chip you have to use for 8K? 4. Have you understood now? Okay. Can you write the address? That's not mentioned here. See, memory requirement for ROM it is 4K. Right? So 2716 is 2K size. Okay. So number of 2716 required is 2. Similarly, 6116 size is 2K. For RAM requirement is 8K for this specification. Number of 6116 required is 4. So now how do you get the address map like you have done last time? See, you will have, how many ROMs are required now? 2 ROMs, right? Okay. So you can write like this. See, you can write like this. The ROM requirement is starting from address 00000H2. It is 00FFH. But you have to use 2 chips. That is ROM 1 and ROM 2. ROM 1 and ROM 2. Okay. What is the range of this ROM 1? This is 2K. And this is 2K. And requirement is 4K. Now can you tell me what is the starting address? 0000H2. 2KB, right? 00007F 7FH. Okay, what is the range of this? Plus 1. 008002 0087FF, like this. Yeah, 008002 00FF. Similarly, can you do it for RAM? What is the address range of RAM? Starting from, it is 8KB. This is very important. All of you try to do this yourself. Don't play with the mobile phones. Keep the mobile phone inside. Right? Do this. Practice this. Then only you will be doing something. Otherwise, you will not do anything. End up with getting off C, D grade. If you want that, I am not bothered about it. Okay. 0800H2. What's the ending address? 09FFH. So it is, how many RAMs are required for you? RAM 1, RAM 2, RAM 3 and RAM 4. Okay, what is the address of this? 08000H2. Calculate. You add 7FF to this. How much? 087FFH. What is the address range of this? Plus 1. How much? 08800H2. This is very important. If somebody doesn't know this, try to update it. I'm telling you now itself. You cannot do even a single problem in memory design if you don't know this. And it's not something very difficult. First standard student can do that. First standard, high school, primary school student can do this. Starting address and ending address. That's all now tell me. Okay? So now the first work you have to do is to get the address map or say memory map. It's very important. If you don't know how to do this, don't write these questions at all. Anyway, you're going to get 0 on that. Don't waste your time. But you need to know. Why I'm telling you this? You need to remember this. These are very important. Okay? This is the first step to do. Okay, after that what you will do? Table, do the table. Can you do the table? Do it yourself. Do the table. See, you cannot escape from the exam. The exams you have to do this. Do you remember? What type of table you have to do? Right, A19, A18, A17, A16, A15, dash, A0. Come on, right? You make a table. Okay? You make a table like this. Now, one column you make it for ROM1. ROM1 starting address, you write here. Right? Have understood this. Now, remember to reduce the time which is taking to write this. You see, first A14 to A19, A18, A16, A15 is all 0, right? It's all 0. You need not represent it here because writing this table is a very long time work. It takes a long time. So what happens is, whichever address lines are permanently 0 in this entire address range, don't write it. Okay, is it possible to do in this address range? Can you tell me? Can you do that? See here, this is all 0, right? This is your A19 to A15, yes or no? This is also 0, yes or no? Come on, you tell me. So in the table you need not put it because it's understood it is all 0. Why? But it is there, you can't completely neglect it, but you do not write it. Once again separate 0, 0 for. Have you understood this? Okay. So next method is for getting a table. Can you just get this table? See here. This is for ROM1, ROM2. I have not written A16 to A19. Why? It's understood it's all 0. Hope all of you are understanding this, right? Okay. So this is very important. You have to do. You cannot escape. You cannot escape. This is in examination. It is going to come. 1 or 2 problems are going to come 100% in comprehensive examination. At least your midterm is gone. At least think of scoring some good marks in the comprehensive examination. Have you understood this? Okay. You have most of the chapters coming from only from memory design and I/O interfacing. Right? That's why I'm telling you, you just make it pakka in every classes. This is not something very difficult. It's very easy. Okay? So once you get the address map, put it in the table. Right? Okay, this is for ROM1. Okay, this is for ROM2. This is for ROM3. Hope all of you got how we get it. Okay, so can you do it yourself? At least try to complete 1 or 2 entries. Come on. Complete in your book. ROM1, ROM2, ROM3. You do it in your book. No. I will not allow anybody to just keep quiet. Do this because if you don't do here, you will not do it in examination also. I've seen all my section answer sheets. I'm not happy with that. Totally disappointed with taking so much of class, so much of pain. Worst performance. Right? I don't know where's the problem. Okay. Fine. Okay, just answer your numbers. Isham, Aditya, Prakriti, Dipti,
Yes, sir.
Arisa,
Yes, sir.
Marvin. See those, just do this. I'm telling everybody, do this. Hello, my dear. Do this. Just be cautious when I call your number. Okay? Hitesh,
Yes, sir.
Zubair,
Yes, sir.
Mubashir, Nagendra,
Yes, sir.
Johan Girish,
Yes, sir.
Mohammed Sinan,
Yes, sir.
Dhairya, Mahendra Patel Dhairya, absent. Vivek,
Yes, sir.
Alex,
Yes, sir.
Himish,
Yes, sir.
Aryan Ramabhadran, Dharma,
Yes, sir.
Saini Suraj, Ramakrishnan Kailash, Naina Sitlani, Said Abdullah. People don't come, I don't know what they will understand. Why should bother? Paridhi Goyal, Jaskaran Singh, Sriramurthy,
Present.
Malvika, Aryan Yam, Tanish, Vishnu, Guru Vishnu, Rajdeep,
Yes, sir.
Rashikesh, Mahendra Davde, Ameya,
Yes, sir.
Adil Shafi,
Yes, sir.
Ratanesh,
Yes, sir.
Venkat,
Yes, sir.
Suleiman, all of it, do this. Do this. Complete the table. Complete entire table. And complete for RAM. So what is shown here is ROM 1, ROM 2, RAM 1. Complete for RAM 2 and RAM 3. RAM 4. So many are there, right? Complete the table. I'm going to continue from this table to the next in the next class. Okay, this design is very important, I said. Prakar Singh,
Present, sir.
Janvi,
Present.
Ishan Kurian. Ishan Kurian is present. Absent. Varshita, Mustafa is absent. Yashfin Mohammed Shifa, Munib,
Yes, sir.
Uday Shankar Maturity, Ved,
Yes, sir.
Sai Shri,
Present, sir.
Lin,
Yes, sir.
Uday Singh, Anand Bhumi, Bhumi Anand. I don't know Bhumi Anand, you will be able to write the exam this time. Yashita,
Present, sir.
Rais Ahmad,
Yes, sir.
Rishin,
Present, sir.
Sharashwan absent. Par, Pratik,
Yes, sir.
Nupur,
Yes, sir.
Nikita,
Yes, sir.
Sofana,
Yes, sir.
Zahid Mohammed. Don't copy from the board. Okay, just do it yourself. Saransh, Harshit, Radhika, Varnika, Ashwin,
Present.
Sneha Sunil, Sania,
Yes, sir.
Syed Abdul Nihal.
Yes, sir.
Don't copy from here. You know how to do that. And you just write because I'm going to start. Can you identify unique 3 address lines. Can you tell me how many address lines will go to the memory now? Memory address line? Of course, A0 to A11, A10. A0 to A10 will go for. Can you get 3 address lines, which is unique to all the 8, whatever 6 now, how many? 6 chips, memory chips you have. Can you identify? Can you see this here? You can see A11, A12 and A15 is unique, right? See, it is 000 for this, 001 for this, 100 for this, and 101 for this, 110 for this, 110 for 110 for this, and 111 for this. So which are the 3 lines going as a select input to the decoder now? A11, A12, A15. So remaining line A13, A14, A16, A17, A19, you can use it for that enable. Right? It's very easy, yes or no? Once you got this table, that's all, you get this. That's all. This is the final answer. See, ROM 1, ROM 2, RAM 1, RAM 2, RAM 3, according to that. Have you understood how we got this? This is final. That's all. Done. This is for 8088 microprocessor. Right? Okay. So practice once again. See, this is the way it works. The complete diagram. This is your ROM 1, ROM 2. Right? You can see address line A0 to A10 will directly go to the particular RAM and ROM chip. Right? And you can see that O0 is connected to chip select of ROM 1. And you can see that this there is a connection here. Okay, there is a connection here. This is connected to chip select of this. And according to that 3 lines, and you can see this is connected to respect to RAM 1, RAM 2, RAM 3. And you can see D0 to D7 data line of the RAM and ROM also connected to the microprocessor. This is coming from microprocessor. And you can see this is decoder logic. A15, A12, A11 is going as a select input. And remaining line is going as a G1, G2A, G2B. Right? Now, using this, any address generated in that particular range, that particular chip will be selected and data will be taken from that particular chip. This is what the memory design for 8086 microprocessor is. Not only 8086 microprocessor, all subsequent microprocessors which you are using today is using this. It may be 1 GB, 2 GB memory based on the microprocessors you have. Right? If you understand this, you can understand all the higher microprocessor designs. Right? I've understood. And this design is unique for that address map only. Have you understood this? That's very important. Okay? This design is for that address map only, which is given as a specification in the problem. Right? So now, how do you get different questions on this topic? Tell me. Different memory maps, different memory chips. Accordingly, you have to design. Okay? Fine. Okay, we'll stop today.